Alright, welcome to the third video in my series on discussing the methods of calculating the derivatives of given functions. In this video, we're going to be discussing the chain rule. We're also going to be discussing the derivatives of sine, cosine, and e to the x. Right below, you can see the formula for the chain rule, which is to be used in instances whenever there's one function inside of another function. So in this case, it would be g of x residing in the function of f of x. Right, so moving on to our first example question, we're going to have 3x plus 1 raised to the power of 4. So for this first, we're going to put it into the formula. That involves first using the power rule. So we're going to multiply the entire equation by 4, then reduce the power to 3, and then we're going to go ahead and multiply it by the derivative of the inside, which is going to be 3, as the derivative of 3x plus 1 is simply 3. Going ahead, we can then simplify this to get 12 times 3 to the x plus 1 raised to the power of 3 as the derivative for 3x plus 1 raised to the power of 4. Now, getting into the derivatives of sine of x and cosine of x. These derivatives seem to form a type of loop. So starting off with sine of x, the derivative of sine of x is going to be cosine of x, for which the derivative of cosine of x will be negative sine of x. The derivative of negative sine of x is then going to be negative cosine of x. And finally, the derivative of negative cosine of x is going to once again be sine of x. So we're then going to use this in another given equation. In this example, we have 4 sine 3x. So first, we're going to go ahead and use our derivative that we just acquired, which is going to be changing it to cosine. Then applying the chain rule, we're going to go ahead and multiply it by the derivative of the inside equation, which is 3x. So the derivative of that is going to be 3. This is then going to give us a n derivative of 12 times the cosine of 3x for the original equation of 4 sine of 3x. Now on to the derivative of e to the x. The derivative of e to the x is going to be e to the x, which is very convenient. So going ahead and using this in an equation, we're going to be using the example of 4 times e raised to the 5x. So for this, to use the chain rule, we're going to go ahead and use the derivative, which is going to be 4 times e raised to the 5x multiplied by the derivative of the inside function, which is this, in this case, going to be 5x. So the derivative of that is going to be 5, which is then going to give us an n derivative of 20 times e to the 5x. Now we're going to go ahead and put a bunch of these ideas together to make one final derivative question. All right, so consider the following equation. For f of x is equal to 3 cosine 4x, all divided by 2e to the 5x. So first, we're going to go ahead and rearrange the equation by making the denominator's exponent negative, so we can then make it easier to use the product rule. So to use the product rule, first we're going to have the first equation, or not the first equation, we're going to have the first function multiplied by the derivative of the second function. So to get that, we're going to use the power rule to go ahead and get, or not the power rule, the chain rule, to get negative 10 times e raised to the negative 6x plus the derivative of the first function, which is going to be negative 12 sine 4x. Since we are also once again using the chain rule, cosine changes to sine, and we multiply by the inside, which is a 4x. Then we multiply all that by the second function, which in this case is 2e to the negative 5x. We can then go ahead and simplify this, which gives us negative 30 times e raised to the negative 6x times cosine of 4x minus 24 e to the negative 5x times sine of 4x. We can then go ahead and then factor out a 6e to the negative 5x to simplify. And then that's all going to be multiplied by 5e to the negative x cosine 4x plus 4 sine 4x. And that is going to be our derivative for the original function of 3 cosine 4x, all divided by 2e to the 5x.